The Germans thought they had the upper hand. It was December 1944. The Ardennes forest was frozen, the fog was thick, and Hitler had just launched a surprise counter-offensive, what would become known as the Battle of the Bulge. American forces, caught off guard, were outnumbered, scattered, and dug into icy trenches. On paper, it looked like a German win. But then, entire German...
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
Formations began to vanish. Not retreat, not surrender, just gone. Ripped apart mid-charge, shredded from above, and turned into chaos before they could even see who was shooting. It wasn't luck. It wasn't just guts or grit. It was a device the Germans didn't even think was possible. A secret weapon deployed without authorization. One that turned Allied artillery into something far more terrifying, a tool of precision destruction. They were called proximity fuses, and their battlefield debut was pure devastation. Here's how it went down. Colonel Oscar Alfred Axelson didn't wait for the green light. He was overseeing an artillery group under extreme pressure in Belgium, and the situation was deteriorating fast. He made the call to use a top-secret piece of tech, radar-equipped artillery shells that detonated not on impact, but in midair right above enemy troops. The official line had been strict. Proximity fuses were only to be used in anti-aircraft scenarios, for fear they'd fall into enemy hands. But Axelson took the risk, and in doing so, he changed the course of the battle. As soon as those shells started exploding above German positions, the results were immediate and horrifying. You're talking about a 50-fold increase in effectiveness. That's not an exaggeration. Traditional artillery shells had to land pretty much right on a target to be lethal. Proximity fuse shells, on the other hand, detonated in the air and rained shrapnel in a wide radius. Suddenly, tree cover was useless. Dugouts, worthless. Camouflage, didn't matter. The fuses essentially made it impossible for German units to hide or maneuver without exposing themselves to a lethal barrage. And the thing is, the Germans had no idea what was hitting them. To them, it looked like American artillery had suddenly become omniscient, like the shells knew where to go. And in a way, they did. The miniature radar systems inside the fuses detected proximity to solid objects and triggered the explosion at precisely the most effective altitude. It wasn't just brutal, it was efficient. This was no longer guesswork. It was science. But that science had a long, expensive backstory. The proximity fuse wasn't some quick battlefield invention. It was the result of a massive, ultra-secret project involving over 100 American companies and thousands of scientists and engineers. At the heart of it was an electronics breakthrough, miniaturized vacuum tubes that could survive the crushing G-forces of being fired from a gun, as well as extreme heat and acceleration. Developing that technology cost $1 billion, a staggering sum for the time, and required building an entirely new kind of manufacturing infrastructure. We're talking about mass-producing 40,000 fuses a day, with obsessive quality control and industrial secrecy that bordered on paranoia. Workers didn't even know what they were making. The military couldn't risk the tech falling into enemy hands or being copied. But all that secrecy paid off, because when the fuses were finally unleashed on the battlefield, the impact was immediate and game-changing. At Bastogne, they held the line. At Malmedy, they annihilated elite German SS units. At the Sauer River, they tore through defensive positions that would have held back traditional artillery. The terrain didn't matter. Whether it was dense forests, open plains, or frozen rivers, proximity fuse shells turned the battlefield into a death zone. And for the Germans, it was terrifying. Now, keep in mind, German intelligence did capture some American shells with these fuses. But they dismissed them. Why? Because the fuses had vacuum tubes inside, and German engineers just couldn't believe that tubes could survive the forces of artillery fire. To them, it didn't make sense. It had to be fake. That critical miscalculation meant they didn't prioritize developing countermeasures. And by the time they realized what was happening, it was too late. Entire German formations broke under the psychological pressure alone. The fuses didn't just kill, they demoralized. Soldiers couldn't find cover. Officers couldn't regroup their men. Any movement risked triggering another rain of fire from above. It wasn't just physical destruction, it was a mental collapse. The fuse didn't just win battles. It broke willpower. This was a pivot point not just in the Battle of the Bulge, but in modern warfare. Before proximity fuses, artillery was supportive, something you used to soften a position or delay in advance. With proximity fuses, artillery became a decisive force. It could change outcomes in real time. And it did, over and over, across the Western Front. That shift didn't end with World War II. The technological innovations behind proximity fuses laid the foundation for the electronics boom of the post-war era. The work done to miniaturize radar components and make them battlefield-ready would go on to influence everything from guided missiles to space technology. You don't get to satellites and smart weapons without first solving how to fit a functioning radar system into an artillery shell. But while the science was dazzling, the human cost wasn't forgotten. Every shell that exploded in midair represented a life, or many ended instantly. And the people who built those fuses. They did it under intense secrecy and pressure, never fully knowing what their work would unleash. These were not just numbers on a chart or blips on a radar, they were people. Soldiers caught in the open. Civilians displaced by the fighting. Factory workers under government surveillance. The fuse was a marvel, yes, but one built with enormous weight. Still, from a purely strategic point of view, the deployment of proximity fuses at the Battle of the Bulge was a masterstroke. It gave the Allies an edge when they needed it most. They were stretched thin, under-equipped, and reeling from the shock of Hitler's last major offensive. But with proximity fuses, they didn't need more men, they needed better tech. And that tech delivered. The Ardennes became a proving ground, not just for bravery, but for innovation. And the takeaway is clear. In war, science wins battles. Technology changes outcomes. And when industrial might aligns with military necessity, the result can be overwhelming. The proximity fuse wasn't just a gadget, it was a force multiplier. A symbol of what happens when innovation outruns expectation. It marked the beginning of a new kind of warfare, where precision, intelligence, and electronics would dominate the battlefield. So next time someone tells you that World War II was won with tanks and rifles, remind them about the fuse that exploded midair and erased whole units before they could fire a shot. If this story blew your mind, or at least your understanding of how WWI was fought, drop a comment below. Let us know what you think about secret tech shaping the outcome of history. And while you're here, go ahead and like, share, and subscribe for more war stories, tech twists, and battlefield game changers. Because here's the thing, the proximity fuse didn't just shift the odds, it tilted the playing field entirely. The Germans came into the Ardennes offensive with tanks, manpower, and confidence. They thought they could break through. But what they didn't account for was the moment their best-trained units would be shredded before they even reached the front line. Let's talk about the forests. The German army had trained hard for forest warfare. The dense Ardennes terrain was perfect for ambushes, concealment, and tactical movement. It worked in their favor during the initial surprise attacks. But then the shells started bursting in the treetops. Not on the ground. Above. That one difference obliterated their advantage. Tree bursts are devastating. Shrapnel sprays in every direction, ricocheting off trunks, slicing through branches, and ripping into anything beneath. Soldiers who would have been protected by canopy cover or foxholes were now vulnerable from above, an angle no one could defend. Standard artillery would have hit the ground and maybe thrown up some dirt. These proximity fuse shells turned the sky into a weapon. Suddenly, the very environment the Germans counted on to give them cover became a trap. At Malmedy, elite Waffen-SS units hardened, experienced fighters were torn apart in open fields and wooded paths. The psychological toll was catastrophic. These were soldiers trained to die hard, but when artillery shells started detonating before they landed, morale disintegrated. Command structures collapsed. Units scattered. Some just ran. And then came Bastogne. The 101st Airborne was surrounded, cut off, and under siege. Supplies were low, and every day brought more pressure. The Germans thought it was only a matter of time before the Americans broke. But what they hadn't counted on was that proximity fuses gave the defenders range. Artillery fire from miles away could be used with surgical precision, dropping death on German assault groups with no warning. Fog, snow, nightfall. Didn't matter. The fuse didn't need a clear shot. It just needed to be near something solid. It found the target. And when it did, boom. German infantry couldn't get close enough for a full assault without being blown apart. The fuses essentially created an invisible perimeter around Bastogne. You couldn't see it, but if you crossed it, you were gone. The Germans still didn't know what was going on. Even after capturing American rounds, their scientists looked at the tiny vacuum tubes and thought, "This is nonsense. No way those things survived a shell firing. No way this was real." They were so sure of their own limitations, they dismissed what was in front of them. That hubris cost them. And you can't blame them entirely because the engineering behind proximity fuses was wildly ahead of its time. Think about it. A miniature radar system, packed into a shell, surviving the extreme G-forces of being fired from a cannon, flying miles through the air, and then detonating at just the right distance from a target. It was absurd. But the Americans had done it, and they'd kept it secret for years. Over 100 companies worked on it. The military kept it so compartmentalized that workers didn't even know what they were assembling. Some made parts without context. Others handled calibration or wiring, never told where the components would end up. Every screw, every circuit, every sliver of glass was part of a massive puzzle hidden in plain sight. The daily output reached 40,000 fuses. That's not a typo. 40,000 per day, at peak capacity. The scale of the operation was mind-bending. And yet it stayed under wraps. No leaks, no sabotage. Just a relentless march toward innovation under the constant pressure of war. Now let's be clear, the proximity fuse didn't win the war by itself. But it's not a stretch to say it changed how the war could be won. It gave Allied commanders options. It made defending positions feasible even when outnumbered. It forced German units to think twice before massing for an attack because any large movement was now a death sentence. And it bought time. Time to reinforce. Time to regroup. Time to survive. The Battle of the Bulge was Hitler's last big gamble. A desperate attempt to split the Allies, capture Antwerp, and prolong the war. But once the proximity fuses came into play, the math changed. The momentum shifted. The Germans weren't just dealing with cold weather and stubborn resistance, they were up against a battlefield where the very air had turned hostile. And that brings us to the ripple effect. After the war, the technology behind proximity fuses didn't disappear. It evolved. The miniaturization of components, the development of rugged electronics, the concept of using sensors to guide explosive timing, these ideas laid the groundwork for the future. Guided missiles, smart bombs, satellites, even civilian tech like aerospace sensors and automated systems trace roots back to the fuse project. It was a quiet revolution. A deadly one, yes, but also a sign of things to come. Warfare would no longer be decided purely by numbers or brute force. The countries that could innovate faster, adapt smarter, and scale production effectively would dominate. The fuse proved that science and strategy were no longer separate lanes, they were now intertwined. And whoever mastered that fusion would lead. But let's not forget the ethical shadow hanging over all of this. Every technological leap in warfare carries a human toll. The factory workers, many of them women who labored in secrecy, often with no idea of the destructive force they were helping create. The young soldiers caught in the blast zones, turned into collateral damage by a machine they never saw. The engineers who had to live with what they built. The proximity fuse was an engineering miracle, but it was also a weapon. Its success is measured in lives saved but also in lives lost. That contradiction is at the heart of modern warfare. The line between brilliance and brutality gets thinner with every advance. And maybe that's the real legacy of the fuse. It showed the world what happens when science stops asking if something should be done and only asks how. It accelerated us into an age where every conflict is shaped by technology, where wars are won not just on battlefields, but in labs and factories, where the smartest weapon often beats the biggest army. Back in 1944, Colonel Axelson probably didn't know he was unleashing the future. He just wanted to save his men. He saw an enemy massing, saw his defenses thin, and made a call that changed history. That unauthorized Order 1 decision turned a secret prototype into a frontline savior. The Germans never stood a chance after that. And now, decades later, we still feel the aftershocks. From missile defense systems to precision airstrikes to the electronics in your phone, the ghost of that tiny radar fuse lives on. The war ended, but the tech never stopped moving. So, yeah, when people talk about WWIA, they'll mention Normandy, Stalingrad, Iwo Jima. But don't forget the Ardennes. Don't forget the frozen woods, the hidden guns, and the sky that suddenly exploded. That's where a billion-dollar secret made its debut. That's where the air itself turned deadly. And that's where the age of technological warfare truly began. Let's be real, no one expected a vacuum tube to be the deadliest thing on the battlefield. Not a tank. Not a flamethrower. A tiny, fragile-looking glass cylinder with some wires and metal inside. But when that thing was tucked into the nose of an artillery shell and fired across a war zone, it turned the tide of an entire offensive. And that's what makes the proximity fuse such a wild story. Because its power wasn't just in what it did but in what it represented. This was the first time a weapon thought for itself. Not in some sci-fi, killer robot way, but in a way that rewrote the rules of combat. The shell didn't wait to hit the ground. It didn't need a timer. It detected where the enemy was and exploded at the exact height to do the most damage. Automatically, that tiny radar brain made the call mid-flight, all in a split second. For German troops, it was chaos. For Allied forces, it was a miracle. And here's what's even crazier: proximity fuses weren't supposed to be used on ground targets. The official policy, straight from the top, was to reserve them for anti-aircraft defense only. Why? Because the tech was too valuable. If a shell didn't go off and the enemy recovered it, the fear was they could reverse engineer the technology. So military brass said, keep it pointed up, not down. Colonel Axelson took that rule, looked at his battlefield, and threw it out the window. And thank God he did. Because what he unleashed wasn't just more effective artillery, it was a whole new kind of psychological warfare. The Germans didn't just suffer losses. They lost confidence. They lost cohesion. They didn't know how to respond to something they couldn't see and couldn't avoid. Every shell that exploded midair sent a message, we can reach you anywhere. And that kind of mental pressure, it spreads fast. It spreads faster than any artillery barrage. Think about it, how do you prepare for a weapon that makes your own tactics obsolete? Forests no longer offered cover. Trench lines weren't safe. Tanks could be surrounded by anti-personnel blasts without ever taking a direct hit. Every German formation that tried to mass for an assault got chewed up before they could get into position. It was like the battlefield had become sentient. Of course, the fuse didn't work on magic. It worked on raw industrial power. Behind that battlefield miracle was an army of scientists, machinists, and assembly workers operating under lock and key. This wasn't just a military operation, it was a national effort. And while the soldiers on the front lines saw explosions, the people behind the curtain saw wire diagrams, voltage ratings, and soldered circuits. They were building death with a spreadsheet. But let's not gloss over the reality: this was war. No one celebrated the destruction in the moment. No one cheered as bodies fell. The fuse was a solution to a problem: survive. When? And this thing. And in December 1944, with German forces crashing down on the Ardennes, survival was the only metric that mattered. And survive they did. The 101st held Bastogne. German spearheads stalled. The momentum snapped. And by January, the last great German offensive of the war had failed. The Allies regrouped. They pushed forward. And just months later, the war in Europe was over. But what stayed behind, long after the battle ended, was the lesson. That war was no longer just fought with bullets. It was fought with blueprints, with breakthroughs, with the minds of physicists and the hands of factory workers. The proximity fuse was more than a device, it was a signal flare for the future. And from that point on, warfare would never again be separated from science. If you're still with us, we know you get it. This wasn't just about shells and explosions, it was about the exact moment when brains beat brute force. So go ahead, hit that like button, subscribe for more deep dives into the secret weapons and forgotten turning points of history, and drop a comment. What's your take on tech changing the course of war? Let's talk.